Hello, bonjour, Kwekwe. My name is Nelson McDougall et je suis le directeur administratif de l'Orchestre du Centre National des Arts. I'd like to begin by acknowledging that we are gathered here on the unceded territory of the Algonquin Anishinaabe people. I am thankful for their stewardship, their generosity. I'm grateful to be able to earn my livelihood here. I was recently reading an article about land acknowledgements, and in it was a quote from Mary Lyons of the Leech Lake Band of Ojibwe, and the quote is this: "When we talk about land, land is part of who we are. It's a mixture of our blood, our past, our current, and our future. We carry our ancestors in us, and they're around us." So I encourage us to remember that it is not only about the land we gather on, but also an acknowledgement of Indigenous people's blood, their past, their present, and their and all of our futures, and the responsibility we share for taking care of the land we are on and each other. I have the distinct pleasure to welcome you in person and online to the launch of our Sphere Festival. Bienvenue pour le lancement de notre festival Sphère. Qu'est-ce que Sphère? Sphère est notre festival pour écouter la Terre. C'est à travers la musique, les arts et la science que nous mettons à l'avant-scène une discussion sur les changements climatiques et la perte de biodiversité. Co-curated by NAC Orchestra Music Director Alexander Shelley and Canadian-Icelandic interdisciplinary artist Dr. Angela Rawlings, over the next 4 days, Sphere brings together Canadian, Indigenous, and Nordic composers, musicians, visual artists, writers, and scientists for multi- and interdisciplinary concerts and events about the sphere we call home. Tous les jours du festival, il y aura un concert. Alexander Shelley dirigera l'orchestre dans 2 programmes. Passionnant, mettant en vedette les œuvres d'Outi Tarkiainen, Alexina Louis, Max Richter, le mezzo autochtone Marion Newman, and violiniste norvégienne Mary Samuelson. The orchestra will also perform Become Ocean by John Luther Adams. This incredible piece won the 2014 Pulitzer Prize for Music and the 2015 Grammy Award for Best Classical Contemporary Composition. In 2019, writers of The Guardian ranked it as one of the best classical music works of the 21st century. So we're very excited about that. Notre concert familial met en vedette pour la première fois en tant que premier chef des concerts jeunesse du CNA, Daniel Bartholomew Poyser. Parmi les artistes invités figure l'artiste compositrice interprète Kelly Battle, la violoniste québécoise Marie Bégin, et la violoncelliste Chris Dirksen, nominée au Prix Juno. With our main partner, the Canadian Museum of Nature, Sphere brings science to the NAC with lobby displays, including artifacts from the museum's collections like the tree cookie. Are you intrigued by that? I hope so. Please come to the lobby and check that out. We are delighted to also be collaborating with friends here at the NAC. Our popular music and variety team will co-present Piksik, Inuit-style throat singers, right here as part of the Fridays at the Fourth. Our friends in dance are presenting Nordic screen dance on the Kipnis Lantern. This is a series of 7 short films that puts a spotlight on dance film artists from all of the Nordic countries. Nous apportons la musique au Musée canadien de la nature avec une chasse au trésor musical intitulée Suivez ce son, qui présente 8 nouvelles œuvres par des compositeurs canadiens et autochtones interprétées par des musiciens de l'orchestre du CNA afin de représenter des spécimens et des expositions. Il y aura aussi des lectures de livres I Talk Like a River, lus par son auteur, le poète canadien Jordan Scott. We will also feature visual arts by Indigenous photographer Meryl McMaster, Finnish-Norwegian duo Eyes as Big as Plates, and Northern Ontario artist Matt Seelin, and much, much more. This brings me to Arctic Imagination, the reason we're here tonight and the event that kicks off our Sphere Festival. We are so pleased to partner with the Royal Danish Library in this speaker series that brings prominent Canadian, Indigenous, Danish, and Greenlandic voices together in conversation around a warming North. I know these will be profound and thought-provoking conversations with our incredible guests. We are grateful to all of our partners, which include Nordic Bridges, the Nordic Council of Ministers, the Harbourfront Centre, Ontario Art Gallery, and Club SAW, and our lead sponsors, Canada's Forest Trust, Mark Motors, and lead donor support from the Janice and Earl O'Bourne Fund for Artistic Excellence. Okay, let's get this started. It's my pleasure to introduce our speakers. Dr. Catherine Richardson has been in, on, or near the sea all her life, a professor in biological oceanography with the University of Copenhagen. Catherine's scientific career spans from meticulous studies of the smallest parts of the sea and carbon cycles in the world's oceans to studies of biodiversity and interactions between humans, plants, animals, and climate. Her research focuses on the importance of biological processes in the ocean for the uptake of CO2 from the atmosphere and how ocean biology, including diversity, contributes to ocean function in the Earth system. Welcome. Dr. Angela Rawlings is a Canadian-Icelandic interdisciplinary artist researcher who works with languages as dominant exploratory material. Her practice seeks and interrogates relationality between bodies, be they human, more than human, other than, non. Meditating on languages as inescapable lenses of human engagement, Rawlings' methods over the past 20 years have included sensorial poetries, vocal and contact improvisation, theater of the rural, and conversations with landscapes. Welcome to you both, and over to you, Dr. Rawlings. Thank you.
Thank you. Hi, Catherine.
Hi, Angela. I think he forgot to say that you and I actually work on the same research project.
Right, which is where we're going to start this conversation.
Oh, good.
Yeah.
Oh, good. I'm glad to hear that.
The last time that Catherine and I were in person together was 1 year ago, and we spent the bulk of our 2 weeks together on a research vessel in between Iceland and Greenland. We were transecting along kind of the Danish Strait in the North Atlantic, and from kind of the northwest end of Iceland all the way about a couple of 100 kilometers south. On the research vessel, we were up to a couple of tasks. One of them was to extract sediment cores from the deep ocean. We did this at several different locations using a couple of different processes. And will you explain the water?
Oh, yeah, I'll explain the water. One of the first things we observed on this cruise was that the water is absolutely not flat in the Irminger Sea, let me tell you. It was a very bumpy trip. And some people we didn't even see the first week that we had with us. But the reason we were out there is that we believe that, well, let me start another place. Let me start with this sphere that we're supposed to be talking about in the next couple of days. Because everybody at the moment, everybody's talking climate. It's climate, 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 climate. And yet, having a climate's nothing very special. Every planet has a climate. It's only a question of how much heat do you get from the sun, how much gets stored near the surface of it, and how does it move around, what does it come into contact with. And every planet has elements or Lego blocks, if you will, coming from Denmark, that were left over from the Big Bang. And on most planets, these things are relatively inert. They don't really react with anything else. Or they not very readily, at least. And some people even say that Neil Armstrong's footprint can still be seen on the moon. I obviously have no idea if that's right or not. But I do know if we had a footprint on Earth from 1969, it would be long gone. And why would it be long gone? Because there's life. Life is what makes this planet special. And we have no idea what life is, but we do know what it does. And it transforms and it transports these elements. And every time it's possible to get enough free energy out from such a transformation, that an organism or an organism group has gone in to do that job. But we don't understand very well how that job is done. And we think that life started in the ocean. Clearly, it's important. And we think that changes in the ecosystem, what plants you actually had there, the tiny little plants, is actually very important in terms of taking CO2 out of the atmosphere and putting it back, going in and out of ice ages. But we don't have any way to check that hypothesis because until recently, the only thing, if you go into the sediment cores, or, things that are in the ocean, ultimately they die and they fall down there. So you get things, just like on land, you get fossils down there. And you can say what organisms were there that fossilized, but it's far from, there's really not very many of these tiny organisms that fossilize. So we don't know very much about nature in the ocean and what it's looked like. So what we're trying to do with these sediment cores is to take them up and extract the DNA in them, because every organism has DNA, and people have been realizing that we can go back and we can actually take DNA, ancient DNA, out of these cores and describe what nature looked like in the ocean in the past. And on this cruise, the one that we were working on, we actually got about 66,000 years back in time, which is pretty good, but I want to go further. And the Germans have just been out and have taken 2 more cores for us, and we hope we were using gravity coring, so we could only just drop a big metal pipe, drop it from 2 kilometers and through the water, and the weight of it, when it goes 2 kilometers, whoom, it rams into the bottom, and we get a core up. But the Germans actually had one where would pump it down, boom, 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 in the bottom, and they brought us back cores that are over 10 meters. So we're hoping that we're back before the last ice age, which will give us the opportunity to describe nature and the development of nature through all this period, and to relate it to climate, so we can better understand this relationship between biology, life, and the energy balance, which is what climate's all about. And really, it's the interaction between the energy balance and life that makes this planet what it is.
Mm-hmm. Exciting, yeah? It's quite, I'm going to take us back onto the ship for a second. It's quite unusual to be an artist invited onto a ship. So I'm also going to go backwards just a little bit, not as far as you did here with the sphere. But I have had about a 20-year practice working within arts and sciences contexts. After I finished a PhD, and my PhD was in theater and performance studies, cultural geography, geology, and archaeology, so mixing between arts and sciences. After I completed that, I saw a call for a postdoctoral fellowship with Queen Margaret II and Vigdis Finnbogadottir's Research Center on Ocean, Climate, and Society. And this would be a partnership between both Danish and Icelandic academic institutions. The person who started this project? Catherine. So this is how we ended up meeting each other. Yeah. And the research vessel came about because Catherine had, in terms of doing the work that you're doing with the research, you invited the postdoctoral fellows to join you. Quite unusual to have an artist aboard a ship of this kind, and there were approximately 10 scientists, 10 sailors, and then just 2 of us who are coming from the humanities or the arts. And the captain of the ship said this was the first time he'd had an artist on board. We were there for 2 weeks. The first week, I was just kind of hanging off of every single thing that was taking place. I'm there to assist. I've got 10,000-year-old sediment all over my hands, working with the sailors to help lift things around, safety gear galore, and asking...
You should see this lady in a hard hat.
Asking all the questions that I can of the geophysicists, the paleobotanist aboard, and Catherine, biological oceanographer, just to learn as much as I possibly could. whenever I have encountered Catherine's research or her fellows' research over the years, I find it one of the most generative things as an artist. It makes me want to start writing and thinking and processing in ways where I can understand where the research is coming from, but also embody it in a way too, so I can imprint or tattoo it on my, not a physical tattoo, but put it into my body somehow to relate to it. Yeah.
I feel compelled at this point to say I was introduced as being a biological oceanographer, and that's true. I was trained as a biological oceanographer, but as you can see by looking at me, that was some time ago. And I have used the past 3 decades, together with a lot of scientists, including one sitting over there in the corner, trying to get out of that box that was biological oceanography and develop a new domain of scientific understanding called Earth System Science, which is all about, we've spent all our time in science, in natural science for the last X hundred years, describing living and non-living things in the universe. And describing them isn't good enough. You won't understand how it all works if you just describe these things. It would be like asking all the doctors that you know with their different specialities. If you put all your knowledge about hearts or lungs or brains or feet or whatever your specialty is as a doctor, put it all into a big pot and stir it up, you're not going to understand what a person is, because it's the interactions between these different parts that are important. Who would have thought 10 years ago that service announcement, I don't have COVID. But I came in close contact with some mold that's still giving me a rough time. But you wouldn't understand what a person is by just understanding all of its parts. It's the interactions that are important. And 10 years ago, you wouldn't have expected your gut flora to be important for anything except your digestion. Now we know it's important for your immune system, for your psychological state, and so it's the interactions that are important. And this new domain that we've been working on, Earth System Science, is trying to understand the Earth as a complex system, where it is the interactions between physics, biology, chemistry, and people that actually make the difference, that make it all go together. And the reason that I wanted humanists in this project from the very beginning is that I see this as being an Earth System Science project. It's looking at interactions between biology and physics in the ocean and climate, looking at how the climate impacts the situation in Iceland itself. The project also has taken cores from lakes on Iceland, 50 lakes. We have data, cores from 50 lakes in Iceland. Nowhere in the world have you had an island that's going to be so described in terms of how its nature has evolved along with climate. And of course, that gives us also the opportunity to see how did people change the nature, because those signals are there as well. And then we have humanists who have been looking at there's 3, well, actually a 4th one joining now, but looking at the people interactions with these changes in nature and changes in climate. So that's why I wanted you on board, and why, but it was interesting because at some point, there are 2 different ways you can get these cores. You can get them with it's a boring piece of pipe, and when it comes up, it doesn't tell you very much. Or you can get it with a piece of plastic. So when it comes up, you can actually, it's not as deep, but it comes up in plexiglass and you can see it when it gets there. And we did that kind of coring as well. And Angela fell in love. She just looked, she said, I want one of those. Can I have one of those? And my natural science colleague said to me, do you realize this takes X number of hours and the ship costs this, and that means that giving her one is going to be, I said, yeah. But you can't say A without saying B. She's here, she's part of this, and she's going to get her core. And she did, and she made an art exhibition out of it. And do you know what? More people have come into contact with what we're doing and understanding how you can use a core from the ocean to tell the history of this sphere and our relationship to it through her work than I'll ever read all of my boring papers.
So, where to now?
We go back to the interaction between life and the rest of the world, because that's where you're good.
Yeah, that's where I like to be, that's for sure. And also, yeah, I think I'm really glad that you're using the word interacting or interaction and relating. I'm thinking quite a bit about relationality, and Nelson read that in my bio a bit earlier. How do we perform? How are we in relation with ourselves, with the other people that we're coming into contact with around us, and with the more than human entities, whatever they might be. And part of what we're exploring a little bit over these days at Sphere is exactly how different kinds of relationships come to be or can become. I was thinking at a point many years ago about how to understand biodiversity loss. And I was approaching it through the lens of something that I know quite intimately, but that I often take for granted, which is my mother tongue, and that's English. So I was starting to think, well, what would happen if I were to imagine a book, if I were to write a book as a kind of closed ecosystem? And we start out within the book with all 26 letters in the English language alphabet being usable, but with every recto verso spread, every turning of the page, you lose one letter. At first, it's the ones that aren't used that frequently, like we lose Z or Z with the first turn. After that, Z or Z is gone, and then X disappears as well, and then so on and so on. This is called a lipogrammatic constraint. So just like we think about sonnets or haiku, a lipogram is a type of poetic constraint that was invented by a group of French writers in the 1960s called Oulipo. And with lipogram, you limit what you can compose with. So in the sense of the project that I was starting to get my head around, I was thinking, well, what if I am removing or taking away letters, and then I have less and less that I can actually compose intelligible words with the farther that I get in. And I am also quite heavily limiting the sonority of the language as well. What does it sound like if I'm only allowed to use certain letters? And this was kind of my first blush into thinking through how I might embody what's happening in this with this really gigantic concept of biodiversity loss. Over those first pages, we end up losing many letters until we're only left with the 15 letters that exist within the English language pronouns. Again, interested in anthropocentrism in a sense here. The letters that are present in that are E, F, H, I, L, M, N, O, R, S, T, U, V, W, and Y. So once I got to that point in writing this book, I thought, okay, so I can only write using these letters now. What do I start to generate, and what does it sound like when I have that kind of an ecosystem of,
I hope that Angela is going to actually read you the poem in a minute, but I want to tell you what happened to me when I heard it. Because as I've as I've explained, what really fascinates me is this interaction between the geosphere, that is things like the climate and elements and so on, the non-living things, and life, and how that interaction between the geosphere and the biosphere, geosphere being all the energy stuff, biosphere being all living organisms, how that interaction really works. And it's not something that we've looked a lot at, and I have a really, really hard time explaining to people why I think it's so important. And people go around and say, oh, well, you know, we could lose lots of different organisms and it wouldn't mean anything for humans. So I don't know that you can really say that, but I've had a really hard time explaining it. So we have this rule when we're on the ship that, you know, since we don't all know each other really well, that every afternoon we meet at 5 o'clock before dinner, and you know, one of the scientists on board, or one of the people on board, tells what they do and, you know, what they're doing on the cruise and all that sort of stuff. And it was Angela's turn, and it was very, very rough. So you wanted to do it up on the bridge where there was light, so you could be looking at the horizon when it was necessary. So we're up on the bridge, and I can see the captain of the ship. Angela can't. And she reads her poem. When you hear it, just imagine a traditional ship captain listening to this. But and he was very moved as well. It just took him a little time to realize what was happening to him, I think. But when I heard this, I came back home and I said, I can't actually tell you what that poem was about. But it just made such an impact on me because it hit me, yes, that's the interaction. And I've written an essay that was in a Danish newspaper that they actually just published it for a second time because there were so many people who were looking for it again, where I referred to this poem, and it then caused several, you've had at least 2 invitations from Denmark to come and perform that poem so it's to explain about ocean and about biodiversity. So it's really made a very big impact, and it's probably the poem in English that's made the biggest impact in Denmark in the world. But I'd really like it if you would read it for them or do part of it at least, because for me it's just so obvious that, yeah, well, we can talk about afterwards what's obvious. You do your thing.
Tak. Thank you, Catherine. No pressure. All the pressure.
I operate best under pressure. I'm sure you do too.
True. You can see how wonderfully it's been treated as I've been traveling, so we'll just ignore the fact that it's a hot mess. This is the first recto verso spread, or the first 2 pages, once we get to the moment when we only have those 15 letters remaining from the pronouns. And there are the rest of the book, which is many pages long, continue from this point. But this is how I entered this limited number of characters that I was working with. That will help. I will not ruin the environment. 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 I will not run the environment. I will not run environment. I will run environment. I run environment. I run iron. I iron. I on. I will. I will iron. I meant I will not iron. Ruin iron. Run. I run. I run the will. I run the will not ruin the environment. I will not ruin the envi. I will not ruin the. Will not. Not ruin the environment meant. Run the will the environment ruin. Ruin the ruin. He meant. He environment. He in. In. Me in. In he then. No ill will. Men not in will ill. In no hen on rue run me. Rue no in on in no men. I not environment. I will not ruin it. I ill not ruin the environment. I not ruin the environment. I ought ruin the environment. I ruin the environment. I ruin he environment. I he invite me. I he invite me. I invite me. I invite me. I.
Thank you. I'm glad we put pressure on you, because for me it's so obvious that yes, that must be, I mean, I'm sure we can use lose species, and for a while the language, I mean, I look at, if species are letters, then for a while you can take them away and you can still put those letters together and it's very understandable. The language is less flowery, but as they get farther and farther away, what they were supposed to do together isn't working anymore. And I found that a really useful way to try and describe why I worry more about the biodiversity crisis than I do about the climate crisis. Not that I don't worry about the climate crisis, don't get me wrong, but when humanity gets control over its emissions, and you know, there's really no excuse not to, because we have all the technologies that we need today, and that when we do it, it'll take thousands of years, so none of us will be here to see it, but the energy balance of Earth will go back to something that doesn't have a human fingerprint on it any longer. It may not be exactly what it is now, but it will not be impacted by humanity. On the other hand, every time you lose a species, it's gone forever. So we can never go back to a biosphere that doesn't carry the imprint of humanity. And since it's the interaction between climate and life or biodiversity that creates the conditions on Earth, then the biodiversity crisis must be at least as important as the climate crisis, which is about energy. And it worries me more because of this, because of the way you've got me thinking about it. It is all your fault.
I have one more question that I'd like to ask you specifically, Catherine, before we shift to a bit of a Q&A. And now I'm going to put you on the spot with all the pressure. You were mentioning to me before we started today that you just recently co-published an article.
It's not published. We sent it in. We've sent it in. It's a chapter we've sent in for a book.
Would you give us a little bit of a sneak peek?
Sure. And I'll actually say that my co-author is going to be speaking later in the week in this series by A Strange Quirk of Fate, Monique Olsing. What we looked at was this interaction between geosphere and biosphere. And it's this interaction which is important. But what happens when you change when the conditions suddenly change on Earth? And we looked at timescales, and we looked at the fact that in the geosphere, there are long timescales. It takes hundreds of thousands of years for the CO2 or the carbon that's in a rock, once it gets out through weathering or whatever, and it goes into the water system, and then it goes maybe through biology and into the atmosphere and by the time it gets back to being a rock again, it's hundreds of thousands of years. Whereas biology, things happen a whole lot faster. So we've got two different spheres. One, things are happening slowly as a rule, others happening much more quickly, but it's the interaction between the two that are interesting. And so in steady periods of, when the conditions on Earth are relatively stable for a long time, and we're in a phase, as we've been the Holocene the last 12,000 years, then these interactions between the two get into a kind of a balance. And it's when you mess up the balance that things happen. And you can mess up the balance when it happens on a short time scale, like when a meteor hits the Earth and does out with the dinosaurs. That was something that on a geological time scale happened very quickly and upset the balance. When the biosphere evolved photosynthesis, it takes a long time for photosynthesis to evolve, but once it's there, you can look at it as being something that happened instantaneously and absolutely changed the conditions on Earth. And then you look at what humanity is doing to the energy balance and the moving of carbon it's been stored for millions of years. It's been inert and not reacting, and we've got it out now. So reacting and making all sorts of changes in the system. And on geological timescale, this is happening instantaneously. So what we're doing is mimicking the conditions that have happened before when there's been a major change on Earth. And the other thing that's interesting about that analysis is the fact that really the turnover in the biosphere is happening on timescales that make it possible to be able to use biology and biological processes to help us negate the effects that we're having otherwise. So it's this idea of trying. I mean, one of our problems, I think, with climate change is that we use models that are developed to work on politically interesting timescales. That means the very immediate future and only to 2100. I got to tell you that the biological stocks of carbon in the ocean, in life, in the vegetation and so on, in the soil, in the ocean and the soil, they won't be in balance. They won't have reached equilibrium or steady state in 2100. And sea level rise will certainly not have gotten to where it's going. And it's like the way we talk about it, we think, oh, well, it stops at 2100 and, then nothing happens. But it's not. I mean, we keep speaking about all this as if humans are above nature, and it's our politicians when they go to Paris or Glasgow that decide what the future temperature of the Earth is going to be. And in fact, for about 4 billion years, it's been the interaction between physics or geophysics and biology that has decided. Those processes are still there, and we're working together with them. We can't just forget about them and decide that it's politicians in Paris or Glasgow that understand and can make the future conditions. So I'm arguing strongly that we need to be much more respectful of the fact that we're not above nature, we're a part of nature.
Catherine, thank you so much. If anybody wants to collaborate with me, I'm happy to write a libretto thinking through this. I know there are several composers in the room and maybe online as well. Talk with me afterwards. Thank you. Yeah. I think we've got time for questions. Guillaume, what do you think? Do we have time for some questions now? Thank you. Are there any questions or comments? Recipes? Love notes?
I really like what you guys are saying. Could you talk a little bit more about the cores? And like in my head, when you were explaining it, and we were talking about looking at the DNA, I kind of got the sense that it would be like seeing DNA soup, but because I feel like the DNA would be impacted by the processes. Do I have to turn this on?
Just so other people can hear, it's already on.
In order for the people to understand here, we need to. Yeah.
I guess I feel like over thousands and millions of years that the DNA would be somewhat degraded and break apart and look more like soup in the middle of the core. And how did you, or how are you figuring out how to pick that apart, and how far into it can you see? Like, can you get a clear picture of an organism, or is it just bits and pieces and fragments and of like shadows of what existed in the past?
Yeah. The question is about the cores and what we can get out of in the eDNA that we can get out of the cores. eDNA being environmental DNA. eDNA, environmental DNA, is a field that is rapidly opening up at the moment. It's been used considerably on land, and yes, you're right. There is degradation of DNA, but there have been all these wonderful stories of bringing out ancient DNA from organisms you find in or mammoths or whatever, but also in going into caves and going through the sediment there and being able to identify feces from humanoids and what they've been eating and so on. And you're absolutely right. Not all of the DNA is intact, but much of it is intact enough to be able to pick up enough sequences that you can match it to. I mean, even when you do a lot of what you do, you never get the whole DNA. You get fragments of it that are big enough to be able to identify what you have there. So I won't say it's a standard procedure on land, but it is getting to be much more standard. Doing it in sediment cores with salt is problematic, and we have. I think it's going to work. I mean, we do have, but how far back we're going to be able to go, and whether or not it's. I mean, we know we can do it at in the relatively recent stuff, but we don't know how far back we can go, and we also don't know how intact it'll be when we get, if it'll be concentrated enough when we get farther back. But people are now using eDNA to, for example, when you have a whale that comes up and surfaces and goes down, they collect water there where and they can identify what animal it was, and people are beginning to use eDNA to do environmental monitoring, also in marine and freshwater systems, to be able to try and identify what organisms are there. And in fact, I've been doing it. I had a student we were working in a peat bog and trying to look at degradation of the ecosystem there. And one of the students was looking at the plants that you had there, which is the traditional way of doing it, and looking at what plants there were, the big plants that you could see. And then I had another student do it in the soil, looking at the fungus that was in the soil. We get a much, much clearer picture of degradation, which is about how much water there is in the system, looking at the eDNA in the soil there. So there's a huge potential. It's a field that's opening up like crazy, and it does seem like a miracle that you can take mud and tell what was there in the past, but you can do it on land. So. And over two-thirds of this planet is covered by ocean, so I sure hope we can do it. You know, another really interesting thing, and this is getting totally off track, but those tiny little plants in the ocean, they've been around for a really long time. And all of us know that the plants that we have on land, it makes a huge difference if you have a redwood forest or a cactus or the desert plants or a nettle patch or a tropical rainforest. It makes a huge difference for food webs. It makes a huge difference for how much carbon gets caught and moved around. So we intuitively recognize that what plants you have in an ecosystem make a huge difference in how that ecosystem works. If you look at the tree of life, there's one branch that's for all animals, including us. There's one branch that's for all the land plants. If we should say this sort of popularly, we could say that at some point a plant crawled up from the ocean, and all of the plants that we have here at the moment are cousins from the first one. If you look at the tiny little plants in the ocean that I study, the phytoplankton, they show up on 11 different branches of the tree of life. They are so different from one another, much, much more different from one another than all the land plants that we have. And we understand that it makes a difference what land plants we have there. How can it be that when we talk about these tiny little plants in the ocean, they make it into our textbook as a little box, a little black box called phytoplankton? So there's so much to, I mean, they're so small that we can't see them with the naked eye. So, of course, we think, oh, well, they're not really that important. They must all be pretty much the same. But the relative size difference between them is, even though you can't see them, the relative size difference is actually bigger. If you do it in terms of volume, it's actually bigger than the difference between a mouse and an elephant. And is there anyone here who thinks a mouse and an elephant go into the food web in the same way, or, you know, operate in the same way in ecosystems? So there's a fantastic world there to be discovered, and we don't even know if it's the same phytoplankton today that it was before the last ice age. And, you know, there's so many wonderful questions we'll be able to address with these data. I just have to live long enough to get them.
Are there any other questions?
Yeah.
Oh, super.
Thank you. So I'm just wondering, how do you think, or do you think we're at the point of using or needing to use geoengineering approaches to help these organisms help us balance out the carbon cycle?
That's a really, really good question. When she asks about whether we need geoengineering, it's geoengineering is when you deliberately go in and manipulate in the, well, it's not just the geosphere or the biosphere in order to be able to try and compensate for what we've done. And it's impossible to be completely against geoengineering because planting trees is geoengineering. So then the question becomes, how far do we go, and under what circumstances do we do it? One of the ideas that's been kicking around, it's not quite as popular as it has been, but one of the ideas that's been kicking around has been to fertilize the ocean in the regions of the ocean that are limited by iron, so the phytoplankton aren't growing because they're not getting enough iron, to fertilize that, and that would make them take up more CO2, and then it sink to the bottom. And there's lots of uncertainties in this, because do you stimulate the right ones to sink to the bottom, and what happens when they get to the bottom, and do you get, and so a lot of people are, oh no, we can't do that because we can't play God. Well, we've been playing God inadvertently for a very long time. And it's hard to be really, really positive about that kind of fertilizing the ocean for that purpose, because you say, oh, well, this is artificial. And yet there was a really, really interesting paper this spring that suggests that there's less iron moving about in those systems today because of the whale fishery. That whales, I didn't know this, but whales, it turns out, apparently have constant diarrhea. And so they're bringing nutrients with them, and also iron, recirculating iron. So the suggestion is there may be less iron in those environments because of something that we did. So we've been geoengineering without knowing it, and now we're talking about should we do it purposely in order to try and negate some of the effects of what we've done. I don't really think the jury's in. My own position on it is not symptom treatment. I mean, if we, for example, put those particles out in the atmosphere that some people talk about that would reflect light or energy, heat from the sun back, so that it would cool the earth. You could cool the earth just like a volcano cools the earth when sulfur particles get into the atmosphere and not as much heat gets to the surface. Problem with doing that is, first of all, you'd have to do it forever, because the moment you stopped, you'd still have these really high concentrations. The other is you'd still have CO2 in the atmosphere. And when you have high concentrations of CO2, it dissolves. I mean, I'll take you all the way back to 5th grade chemistry here. Hang on to hat and glasses. If you have a membrane, and on one side of the membrane you have a concentration of a gas, for example, CO2, and on the other you have that CO2, then the concentration will try and get into equilibrium. They'll be the same on either side of the membrane. Now, if the membrane is the surface of the ocean, and you put more CO2 into the atmosphere, then you're going to get more CO2 in the ocean. And when you put CO2 in the ocean, or when you get CO2 in water, you get carbonic acid. And carbonic acid, then, so you're getting a more acidified ocean, and there are very many organisms in the ocean that make calcium carbonate, and that dissolve. I mean, that would still be there, still be happening, even if we were doing symptom treating. So I don't think we should use geoengineering to symptom treat. I do think we have to think about manipulating the biosphere and geosphere in order to be able to address this. But I'm not ready to go. I'm not ready to go full speed on this and say I think we should fertilize the ocean. But I believe that we are standing with our backs against the wall and a knife to our throats. So I think we do have to study and try and understand all of the options that we have out there to try and get things back in balance. So that was a sort of, I'm on the fence, but I don't think you can say absolutely not when we're in the situation that we're in.
We have an online question from the live stream audience. I have heard about urban microforests to increase biodiversity. Do you know of any projects like that happening in the oceans?
Well, yes, actually. It's not quite the same as, I mean, obviously, the nature in the ocean is, I don't know where the camera is. I don't know how I'm talking to this person, but I'm trying. Nature in the ocean operates by some different rules than nature on land. And for one thing, on land, we all know it's access to water, which is incredibly important for deciding what kind of plants and so on are going to grow there. And I'm sure you haven't laid awake at night and worried about it, but access to water is not a problem in the ocean. So that means there are different rules. So you can't exactly move what you have from urban areas out to the ocean. But one of the things that we've done around the ocean is that we've gone out and we've fished up stones and brought them in to make harbors and to make dikes and barriers. So in many places where there were stone reefs near the coast, we've taken them away. Now, it turns out that stone reefs are really, really important in terms of ocean productivity, because when you have a bunch of stones there, it makes the water shallower above, and the light can get down to the rocks, and plants can grow there, and they're very important for fish and all sorts of organisms there. So there are lots of examples of trying to create new reefs, or to restore reefs to try and make biodiversity hotspots around these reefs. And in fact, a lot of it's turning out that a lot of the bridges and stuff that we're building in the ocean have turned out to be very, very good for some forms of biodiversity. It may change the kinds of organisms that you had there originally, so you have to be very careful about that. So there are good examples there. We're also, I know of at least one example that, and this is in Denmark, where Denmark is a farming land, a country, and from the mid-1800s filled in the shallow area, ocean area that it could to make new farming land. And something like a third of the area of the ocean area where the depth of the water is under a meter or less were filled in to make land. Now that's really productive for fish food, bird food, and so on, because again, the light gets all the way to the bottom. And now some of that farming land is not, with all the crises that farming is going through, it can't pay to farm it. So I know of a project trying to give it back to the ocean. And, it's not a question, it's not that easy. It's not, if you want to give farmland back to even not in the ocean, but if you want to do it on land, it isn't enough to just put the tractor in the garage. I mean, you have to get some of the nutrients out. There's lots of things that you have to get the microflora right and all that sort of stuff. And so learning how to restore nature is something that we're looking very much at the moment. But so yes, we do see some biodiversity initiatives in the ocean. But of course, the problem with biodiversity, both on land and in the ocean, is that it doesn't have enough space. That's why the E.O. Wilson went around with this half-Earth idea, that we should leave half of the Earth for other organisms. And right now there are some pretty ambitious goals, certainly in the EU, but also internationally. They haven't managed to get the Biodiversity Convention, the new COP in the Biodiversity Convention is supposed to be happening in China, and it's not happening because of COVID. So they don't actually have the new, they have a draft which says that we want 30% of both ocean and land to be in some kind of protection, and a third of that, 10%, to be so protected that you can't fish or whatever. So there are lots of efforts at the moment to try and make more space for biodiversity. I don't know where you are, but...
I saw one question on this side. Oh, there you are.
Professor Diana Lieberman.
Hi, Catherine. So my question is for both of you, and it's about the potential of collaboration between the arts and climate science. And the thing that concerns me, because I've been trying to collaborate with artists as well, is the sense of urgency I have, and whether collaboration with the arts can expand and inspire beyond the people who are already convinced to act or who are already worried. So I think the question is, what does the collaboration add to the sort of power of action that we need at the moment?
I'll attempt to start this one. Am I turned on here? Yeah, perfect. I love this question. This is also kind of this is exactly the question that needs to be in the room at the outset of this kind of festival as well. When we have so many people with vested interest and curiosity coming from different disciplines, different expertises, whether within the arts or sciences or elsewhere. I'm returning again to relationship, how to form relationship, and also how to not jump immediately into collaboration or an interdisciplinarity, but to lay the groundwork or foundation so that these conversations can start to occur and collaboration can potentially grow out of that. Cross-disciplinarity or interdisciplinarity can grow through that. My experience as somebody who's worked within both arts and sciences is that first and foremost, there's such intimacy, such intimate knowledge that's present within any discipline that somebody is engaging. The specificity of the vocabulary that's present, how they are using words to describe the kinds of analogies that are arising in order to communicate their concepts. It can take a while to kind of find a commonality or even an understanding definitions. I know for myself, when I was starting out the PhD, which I mentioned was in 4 different disciplines, where I had supervisors from these 4 disciplines, I realized about a month in, as we were discussing the approach to site specificity, which I would take on, each of the different disciplinarists approached the definition for the word site, S-I-T-E, in a completely different way. And that meant that we weren't actually even able to start a conversation together until we sat down in a really rudimentary sense. Well, what do we actually mean when we use this word in this way? And even at that point, how do we start to understand the language that we're using in relation to somebody else's field, so that it is providing an opportunity to expand how we are thinking, how we're conceptualizing or approaching. One of the things that, as I mentioned before, I feel it's quite generative to hear Catherine speak, and that has everything to do with the analogies that you are using as you talk. When you are speaking about these different time scales, I immediately want to start thinking through that in a practice research sense from the arts. So, okay, how can I approach this in an embodied sense? How could I work with language or with sound in a way that would communicate or analogize back in this direction, how to share this information, and vice versa, because science communication is often so hinged on analogies or metaphors. I mean, we're coming out of the literary arts with these kinds of things. So people who are working in the physical sciences, especially fronting with science communication in such extraordinary and urgently needed ways as Catherine does, having cross-disciplinary conversations with people whose intimacies and expertises are within those art frames, I think it's quite exciting. I don't know if I answered anywhere near what you were asking, but
let me try and pick up on that, because I hear Diana saying we're in a mill of a Hess, and is this going to help us get out of it? And I don't think it is in the immediate. I don't think it's going to get more people, on the barricades for climate or whatever right now. But what I do think, and why I invest in it is so important, is, like it or not, we don't consider, it isn't natural science, unfortunately, that has a big role to play in culture development and the sort of societal views and attitudes and values. And I do think that the humanities and the arts do. And if, as I ended by saying that I think, we need to acknowledge, it's just disappeared from the culture that we're in, that we are a part of nature, that we own it, and the Bible says we do. It's there for us to use. And if we're going to change, and I think it's so fundamental to change that kind of thinking, and I don't think scientists are going to be able to change that kind of thinking. And I think it should, and I do think it will come from many different things. But I think one of the most important things that we can do right now is to look at our legal systems and to look at the way laws are written. In Denmark, we supposedly have the most advanced or the most ambitious climate goal in the world, and yet it says, okay, the goal of this law is to reduce our CO2 emissions, And then in the very first paragraph, it says, and there are 9 guiding principles. And those guiding principles are, it should be as cheap as possible. We should not damage the competitive ability of Danish companies. We should make sure that the public finances are healthy. We should preserve a welfare state. We should make sure that the low end of society doesn't get hurt harder by anybody. And I can't remember the last 4, but it's the same sort of idea. Nowhere in that law do we mention biodiversity. And yet more than half of our so-called renewable energy is from biomass. And so we're completely ignoring that interaction in that law. And if it was instilled in us, if we respected and understood that we're a part of nature and we have to do a 360 on all of the interactions that we have, then I think that, and I think that law would and should look differently. And I think that's only going to come if we're working at it from both directions. So that's why I really invest, I won't say heavily, but this is why I invest in this kind of collaboration, because I think we need a new narrative in our society, and narrative doesn't come because scientists say, look, the house is on fire.
And I'd also just a tiny bit add to that too, in going back to the sense of relating, it's also taking the time to listen and to understand across the different disciplines. It is taking, I know that it seems a little bit maybe counterintuitive to be taking time when we are in an urgent, we feel the urgency. We are using words like climate crisis, climate catastrophe. I've been keeping an ongoing list of the different ways in which I hear this described. It's been changing over the last 100 years. Climate change as a term is about that old. And rather than feeling on a personal scale, amped up, adrenalized, cortisol overproduction, hypertense, in that traumatic or shock reaction place, finding ways to come into a moment of breathing a bit more deeply, calm, activating our listening skills, what's happening here, what's happening in our interactions immediately around us, and then as far as we can hear in any directions, actually just being present with ourselves and our bodies so that we can have the conversation without it being at this, even though it's at this. Yeah.
This will be our final question.
Thank you. Sorry for the boring, but I was thinking about something. When you were speaking about the tree of life, the fact that we got a lot of studies about the species on land and also the animals, the tree of life is very developed, but about the ocean and the species on it, is, from what I was understanding, for this kind of a Pandora box where there's not that much of knowledge about it. And when I was seeing the picture behind you of the Earth and the sphere about it, I don't know why, but I was trying to think out of the box about it, and I was thinking how beautiful it is. And outside of that, we got the International International Space Station, and over there we are doing studies. And I was wondering, I'm guessing that most of the studies that we are doing over there, it's about land or species on land or animal studies over there. So I was wondering, are we doing a lot of studies on the ocean species over there? And I was finding that interesting because when you see the astronaut, when they're training to go to space, they go to swimming pool because the gravitation is kind of similar. So I was wondering if there's a lot of studies over there, or is there a lack about it, and are there going to be studies about it?
Well, the ocean is exceedingly understudied. And I actually asked to have this picture here, and then I never really used it. But I'm glad you brought it in, because I think I mean, the reason I wanted it here is we've all seen it, and we've just never, most of us have never really worried or thought about what it was telling us. And one of the first, there are two major things that it shows us. One, our ancestors made a terrible mistake when they called this planet Earth. It should have been called ocean. And that makes it all the more amazing that we really know so little about the ocean as we do. But of course, as I say, those organisms are small. Many of the organisms are small. And when you look out the window here, and you know, the first thing you see of nature is a tree. Well, why is a tree big? A tree's big because it needs to get water down there in the dark stuff, and then it needs to get water transported to there where the factory is. And the taller you are, the less competition you have to get light. So, you know, those kinds of rules don't work in the ocean. So when you think ocean nature, you think fish. Everybody thinks fish. And, you know, on a good day, maybe a whale. But nobody thinks about my tiny little plants. And I'm convinced, I mean, it's the microorganisms on this planet that have really been busy in terms of the interactions between the biosphere and the geosphere. But no, the ocean is terribly understudied. And of course, the other thing that this picture shows us is that the Earth doesn't have an umbilical cord. And you say, well, of course it doesn't have an umbilical cord. But what does it mean that it doesn't have an umbilical cord? It means that once we've used the Earth's resources, and make no mistake, it's the Earth's resources that are making us rich. Nobody can eat money. Nobody can put money on to stay warm or live in money. Money has always been a proxy for natural resources. Our ancestors understood that. They bought and sold from each other with naturalia. And then we realized, well, you know, she might not need bread today. She might need it next week. Here's a proxy. You can get your bread next week. And it was money. And for a very long time, we had gold as the standard behind our money. We don't anymore. We've completely divorced it from resources. But that doesn't change the fact. It's the Earth's resources that that give us our richness, our wealth. And they're limited. And the other thing that the missing umbilical cord means is we can't really get rid of our waste. And that's the problem with climate change. I mean, as a biological oceanographer, I'm disgusted at the discussion we're having now about plastic in the ocean. We've been throwing out plastic since the 1950s, knowing full well it was basically non-degradable in the real world. That's why we like it. And we've had this picture or pictures like it since the late 60s, early 70s that show us, it doesn't have anywhere to go, and over 2/3 of the Earth is covered by ocean. Where did we think the plastic was going to go? How could it take 50 years before people said, oh, you know, no one told us it was in the ocean. Well, where else was it supposed to go? We go around and we say that less primitive or more primitive peoples lived in harmony with nature. No, they didn't. They used nature for everything they needed. They took the game and they let their waste products fall wherever they were produced, and then they realized, not working. Water polluted, getting sick, running out of game. We need to make some rules here. So they were so close to the interactions that they had on this planet that they managed them. Our problem is we have a global economy, and that removes us away from the interactions. We don't see the poor child in Bangladesh that makes our clothes. We don't see the biodiversity in South America that gets displaced because of the fact we need soybeans to feed our pigs, or the plantations for palm oil in Southeast Asia to go into all of our food products. So that's what we need to be doing now, is getting ourselves back into these interactions. And this is where, again, we come back to how art can help us understand those interactions, I think, maybe better than a scientist standing and pointing at a picture of the Earth. Thank you.
Thank you all so much for listening.